Hi everyone, thank you for coming. Yeah, we are really excited to present today. My name is Iveri, this is my colleague Jose. We are software engineers at Adobe in a cloud infrastructure team. And today we're going to talk about how we do software releases at Adobe. And we are going to share some of the results that we've got, what our pipeline looks like, and what are some of the challenges that we faced while working on this project. And before I begin, I'll give you a quick context on the product that we are working on, because it informs some of the decisions and requirements that we have. So the product is called Adobe Experience Manager. It is a content management system, basically a platform where customers can build their websites, customize it in many different ways, like front-end, back-end, publish content, yeah, serve it to their clients. And all of this is deployed and managed on the Adobe-owned infrastructure, which is Kubernetes clusters. All of this infrastructure is deployed there. Now this platform itself is composed of many services. So together, all of these services work and bring some of the capabilities that this platform has. And in our organization, many teams own various services, and every day we have quite a bit of velocity of changes that are coming to the system. So security enhancements, like feature work, every day we get like dozens of commits that get into our production systems. So as an infrastructure team, what we need is to match this engineering velocity, right? And enable our engineering teams to deploy their changes to production reliably. And that's where our project starts, basically. Now, when we started thinking about continuous deployment pipeline, we started with like high-level requirements, what we needed, like what's important for us. And it's three things. One is velocity. Again, we need to match our engineering teams. And again, we have like dozens of changes from these services. So we need to deploy them fast. We need to deploy every day, basically, to our production environments. Second is quality of service. So when we deploy to production, it has direct impact on our customer websites. So we can't deploy something that might break or even degrade customer website performance, right? Because it's critical for them. So we can't compromise on the quality of service. So this becomes tricky, like how you balance how frequently you release and how you prevent regressions, right? So that was our second requirement. And finally, it was flexibility. When there is some security patches that we need to roll out really quickly, that does happen like within a day, or we have a regression that we need to roll forward or roll back. These things happen, and we need this break glass kind of procedure where we can roll out something really fast, within an hour, basically, to all our environments. So this is what we started from, and you know, this all sounds sensible, but then we have one problem, which is the scale that we operate in, that introduces some challenges, and Jose is going to talk about this scale.
Yeah. First of all, I'm super excited because I thought we would have like 5 people at 6 p.m. and like this is amazing crowd, given my expectations. So kudos to you guys for being here and having the energy to keep it up. So I don't know how many of you are part of a team that manages Kubernetes namespaces. Can maybe just get a raise of hand just so I know like if any of you has knowledge of this. Okay, good, 3, it's already a good number. So if you do that, you know that it can become quite cumbersome to manage a bit of a few fleet of namespaces. And here we're talking about around 15,000, which like by now it could be like a couple thousand more. And let's say that in very simplistic terms, each namespace is a customer website. So these are websites that many of you are using on a daily basis, and they're hosted in Adobe Experience Manager. So you can see that rolling out code to any of these namespaces can be quite risky, right? Because we could be shutting down the business of a customer, and that results in like millions of losses and so on. So it's a very risky kind of deployment, and we want to make sure that if there's any issue with the code, we at least impact as few customers as possible. So yeah, that's just an intro on the numbers that we're dealing with. These 15,000 namespaces have around 200,000 services because like these instances of Adobe Experience Manager like require multiple different services to work. So whenever we're rolling out code to each one of these customers, it involves like restarting multiple deployments of Kubernetes resources and so on. So each one of those resources is a risk. Now, I wanted to start with where we are today. So this is the results of the implementation of the system that you will see here today. And we are able to roll out code on a daily basis to all of these customers. And each one of our engineers waits on average maybe 3 days to have their changes being used by customers, which is really good metrics given the scale that we're working on. I think maybe you are starting to see a pattern here. Like we use DORA metrics to basically measure our baseline because we wanted to understand where we were initially and what we improved at the end of the initiative, right? And DORA metrics proved a really good way to do that. And this is the rest of them. So we have a very low change failure rate, and we can restore services in an hour. You will see how. But one learning that we had is we didn't want to couple ourselves too much to the DORA metrics because maybe you can use them in a certain project, but maybe it could be that it doesn't fit exactly what you're doing. And in our case, we added some additional metrics. One of them was commits per deployment. So here we wanted to see how risky are the deployments that we're doing. So basically, we want to measure how many changes each version has, so that you can understand like how big are the deployments. If my on-call team has to debug a version, how difficult will it be? Like how big is the change log that they need to look at? And as of today, because we're doing daily deployments, we can lower this number to like 3 commits per deployment, which is super good. Yeah, and now moving on to the infrastructure that supports this, we're going to talk a bit about Prometheus, Thanos, some observability stack. So yeah, passing on to Iveri.
Yeah, so yeah, we can start from how our infrastructure looks like, right? Like where are we deploying these services? So as we said, like across our fleet of clusters, which we have like around 50 clusters globally, across them we have 15,000 namespaces. Now each namespace is similar to each other. They're not identical, but they run kind of similar set of services. And as we said, these services are what makes the Adobe Experience Manager platform, right? So we have several of those that need to work together to bring these features. Now each of those sets of services are running in replicated manner because we need high availability, right? So there is several replicas of them running. They are also dynamic in nature because if we get a higher request load, we horizontally scale out, right, to meet the demand. If we see that we need more memory or CPU, we vertically scale up. So these namespaces in terms of CPU and memory consumption are also going elastic, right? They increase and reduce in size. They also differ a bit in terms of what cron jobs and kind of ad hoc jobs we are running and what kind of configuration surface they have. But profile is the same, so we treat all of them kind of the same way. So we have these namespaces with these services, and when we release code, we release changes to these dozens of services in each namespace. Now, how do we do that? We do it through a set of Kubernetes controllers, and it's a mix. We use some open source controllers for this deployment orchestration and some in-house controllers. So very simplified view is this. On the right hand Yeah, or on the left-hand side here, you see Flux controller. So this is an open source project, FluxCD. They provide Helm and source controllers. Basically, all our applications are packaged as a Helm chart, which is like a package management for like a lot of times we are using it in Kubernetes, right? It has all the YAML resource definitions, CRDs for Kubernetes. So we define our application in single Helm chart, we version it, and then we use the Flux controllers to one, discover these Helm charts, download them from our Artifactory, and then install them, right? So these Flux controllers watch across our namespaces and react and then install them. Now, when we create these Helm charts, we need certain information, right? Like what version we need to use and what configuration we need to apply, right? And this needs to be created, right? That's what Flux controllers react to. So to do that, on the right-hand side, we have our own custom controller called orchestration controller that knows all this information of what version to use, what configuration, and it creates these resources in each of these namespaces. And that's on a high level how the deployment works today. Well, before we even started this project, right? So with this setup, technically, we could release software across all of these namespaces right away. Like there was nothing preventing us from like doing this from technical perspective, like and deploy everything all at once. But if we did, we would be breaking a lot of stuff, right? As we said, like these requirements that we have on quality of the service and like making sure we're not breaking customer environments, we would break for sure. So this was not enough, right? And the next steps we took is understanding this problem and how we can overcome it, right? Like what do we need to change in the system to make this happen? And yeah, maybe you can talk about what was these problems, right?
Yeah. So the way that we always envisioned this, and we were already kind of doing this, so it was a feature that we had to support. All our deployments are done based on rolling restarts and canary rollouts. So you always have like the newest version of the code being started up. As soon as everything finished starting up and it's healthy, we shut down all the rest, right? This is good because yeah, you can have zero downtime deployments, but when you're working with so many namespaces, you will see that it can create very funny issues. I'll talk a bit about it a bit later, but it is a requirement to achieve fast releases. Like you will have to have canary rollouts in a service like ours, which like serves a customer website. You cannot have downtime, so it's a requirement, right? We also need like validation metrics. So if you think about it, we want to roll out things quickly on a daily basis. We cannot have engineers looking at the deployments one by one because there are like 200,000 services. So we need to figure out a way to define some very simplistic, high-level validation metrics that a simple system can look at and decide this code is healthy, the rollout can continue, or it's broken, let's stop and look at what's happening, right? So, yeah, and then, yeah, this kind of relates to what I was already saying. You need to correlate these metrics with the version that you're releasing. So basically, each version of the code as a set of metrics that we are observing, and if based on those metrics you decide if it's green or not. And you will see that like these metrics are very, very simplistic. I think we have a slide a bit forward with them, right? I just want to make sure I don't miss on that point. Anyways, so the metrics we set are things like you cannot look at things like exceptions on pods or things like that, because at this scale there will always be an exception. Like you will always have a service that some team developed that is erroring out because of some reason that is averse to you. So we had to abstract from that and we had to look at the bigger picture. So what we did is we created a set of metrics like percentage of completed rollouts, percentage of rollouts that are failed. And when I mean a rollout, I'm saying basically we start deploying the version to the namespace, right? And as soon as all the services restart with using the new version of the infrastructure, the deployment is considered as complete. And that counts as like a successful deployment. And as soon as these numbers start increasing, we have like 20, 30 like percentage of namespaces that restarted fully. You know that the version starts to be like, there's a higher chance that this version is healthy, right? Because most of the namespaces restarted, there's no issues. There is a funny question that someone can ask in the end, which is, why don't you care about exceptions? I'll give you that idea. Food for thought. I think we'll have time for questions, so let's continue. Yeah, so Thanos and Prometheus, as I promised. So go ahead.
One thing I'll add on the validation metrics, right? In addition to what Jose said, so yeah, we can't look at the granularity, right? So we need to like abstract a bit out. But to give you like a specific idea on the metrics that we look at is in Kubernetes, for example, you have liveliness, readiness probes, right? Like which are very simplistic in a way that you don't put too much logic of your application into it, like dependency-wise, but like check on a very low level, like what is the minimal set of things that need to work out for your application to be receiving traffic, right? So we take all these metrics, readiness metrics and liveliness metrics into account, right? So if they're green, that means that it's good, right? Now, in addition to that, just those two are not enough, right? Because you could introduce something, a regression, those two metrics can be fine, you could be receiving requests, but then you could be erroring out, right? Like serving blank page or something. And those are caught by our canary style of rollouts, right? Where when you have a canary style of rollout, you define a set of metrics where you say that, okay, if these are green, I will say that our canary version is healthy, so I'll move forward. And to give you an idea, these are typically red metrics, right? Like what is the request error rate? Like, for, I don't know, like 500 errors, right? What is the duration? Are we increasing in the latency, right? These thresholds. So when we talk about high-level metrics, we talk about this, like liveliness probes, canary style of rollout metrics we incorporate. And when they are green, we say that, okay, the rollout is good. And we don't care about the log level, like exceptions or whatever might happen there. So we have these types of metrics for each service, right, in each namespace. Now the challenge is that we need a global view of it, right? We need to understand what's happening across 15,000 namespaces, 200,000 services, and we need to make sure that none of it is breaking, or if it is breaking, it's not related to us, right, because there is other factors too. So here, observability comes in, and it's a challenge because the granularity, the amount of metric series generated from 200,000 services, if you are not careful about it, it can break a lot of things. So our setup is following. We have a number of Prometheus services with low retention rate of metrics running, scraping subsets of namespaces. So we are kind of like horizontally scaled out there, right? Each Prometheus server is responsible for only a small amount of namespaces, and we have many of them, and it's not so expensive to run them. But the problem is that we don't have a single endpoint where I can get view of all our environments, right? And for that, we use Thanos. Thanos is another open source technology which can ingest these Prometheus metrics and can store them for long. So it's a large tenant kind of setup that can scale horizontally in terms of the storage capacity. So the setup is Prometheus scrapes all the metrics that we have from these services. Then it reduces granularity there with recording rules. So it drops a bunch of labels that we don't require. If we require them, we look at specific Prometheus for debugging, but on high level we don't. So we drop them, and then we push the metrics, like these filtered metrics, to Thanos. And that way we can ingest a lot of them from all these services, and we can have a global view. And Thanos becomes one single point where we have like overall picture of what's going on. So with that, we are moving... this is the slide, yeah. So we have this observability, right? And we have the validation metrics, so we can tell when something is healthy or not. And all that is left to do is to have this binary flag, like, is the rollout good or not? So one way to say it is we look at all our services and say if we have 100% of them green, if 100% are good, then we move on and say that our rollout was success and our new version of software is good. But unfortunately, that never happens. We never have a 100% success rate for many reasons. Because these services also depend on third-party code and stuff, and things can break not related to it. So instead, what we do is Jose already explained it, but we compile some like even high-level metrics, mostly three. Like we calculate percentage of namespaces that are successful, meaning like all checks pass, percentage of metrics that are degraded, meaning that they are not in a failed state, but we see some performance issues in latencies. And then percentage of namespaces that are failed or that didn't get the rollout of new version yet. So we look at all these sets of metrics, and we apply some SLOs on it, right? Like what's appropriate threshold that we can live with, and like practically speaking. So we have that, and then another thing we have is if we pass that point, we also compare, well, how is this new version of software doing in comparison with the old? Because even if they pass these arbitrary absolute thresholds that we imposed, we don't want to make things worse as we are bringing out new versions, right? We want actually to make it better. Because if we keep on like making small, introducing small regressions and like 0.01% increase in failure thresholds, soon it will be like death by 1,000 cuts. And so we basically compare between stable and canary version and make sure that there is no degradation between these two. And yeah.
Yeah, I think we already explained this part.
Yeah.
I'm going to move forward. Wait, I'm moving backwards. Ah, okay. Yeah, so just situating myself. Yeah, so we already have all these metrics in Thanos, right? So the next part is basically acting on those metrics and rolling out the code. So what we did is we basically have this in-house, very simplistic orchestrator that looks at Thanos, looks at the high-level metrics. What's the percentage of namespaces that that are like failed? What's the percentage of completed? And then we have quality gates. So basically, it's some very like simplistic heuristics on this orchestrator that classify like the release as green or red. And if it's classified as green, it pushes it to our release pipeline, right? So it's really a very simplistic like Golang application that basically reads metrics, fetches them from the server, and yeah, sets the flags as green. Now, even using these metrics, like there are still problems that can come up, and this relates to what I said earlier about the funny issues with Kubernetes at scale. So you still need to be prepared to manage risk. Like even if you have a release that in stage had like 100% of your stage namespaces like successfully deployed, when you go to production, like you could still see issues in the customer environments. And we really want to avoid that. So one of the things that we started seeing, and this relates to the rolling and canary rollouts that we mentioned earlier, is that when you're doing this kind of rollouts at this scale, it can be dangerous if you're not careful and time them properly. So because when you have like, let's imagine this is the old pod and you spin up like the canary instance, which has the new version, for a while everything is starting up, like you will have 2 pods running, right? Well, if you have thousands of pods in the same namespace or in the same cluster, this means you are essentially doubling the load for a while. And this has actually this happened in the past, like this is a kind of a practical example, yeah, where we essentially blew up the Kubernetes API server because we had too many services that spun up and there were so many operations being requested to Kubernetes that it just blew up. So even after knowing that the deployment is green and it can move forward, you need to be careful at how you move forward. So what we needed to do is find a way to like control the release scope so that we are not rolling out to everyone at once, and we have like a controlled way to do it that makes sense and kind of prioritizes the environments accordingly. So in a very simplistic way, this is what we decided to do. As an engineer, when you push code to the infrastructure repository, anything that goes to the main branch is immediately deployed to all the stage environments. So you have, like, you can do immediately changes in the span of like 30 minutes. And for 3 days, we keep that there. And we have like a pretty big team using these environments on a daily basis. So we can be kind of confident that during these 3 days, if there's a huge problem, someone will for sure figure it out. After these 3 days, we deploy it to Adobe environments. This is things that manage Adobe public websites or internal tools. And we keep that there, and if everything is green, if after deploying we see that there's no alerts, on call is not pinged, yada, 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 you know the drill, we start doing the official production rollout. And this is essentially where we had to be careful. So we had to create percentiles. So basically, we try to create like groups of customers and split them by percentile. So you always deploy a new version of code to the first 5%, and then you go from there. And in any of these percentiles, if the version orchestrator looks at Thanos and it starts seeing like the metrics being a bit sketchy, it stops everything. So if there's an issue that, and this is very good because we have a pattern where, because this system has so much customer configurability, there's a lot of problems that only appear after the things go to prod and are used by the customer. So, and in that case, if that happens in a large number of environments, the rollout is stopped. And this is a train, right? So we just stop the train, and we can always push a new version with a fix quite quickly, because you remember the DORA metrics allowed us to like push code quite quickly daily. So we stop the rollout for a day, we think about how to do things, and we push a fix in case anything happens, let's say, on the first 50% of customers. And this, until now, has been quite successful. We didn't have any major thing happening, even though we've been rolling out changes for a year now, because the percentiles are so split. And of course, as our customer base grows, we'll have to think about ways to have even more percentiles, because you always need to kind of make a calculation of how many services can you be restarting at any given time in your clusters. If you support more, maybe you could have like less percentiles and just be quicker with the release. Yeah. So now into a more pragmatic thing. I'll let you talk about it. Maybe you wouldn't expect like seeing a Slack icon here, but I'll let Iveri go through it.
Yeah. Yep, thanks. Just one final thing about the cluster thing. Like, we have this problem with clusters because you want to clusters to utilize them, right, to the fullest. So you don't want underutilized clusters, meaning like you're wasting CPU and memory and resources. So we try to like have like a high utilization rate, right, like how much nodes we actually use in the cluster. But you know, that has a problem where like if you have high utilization rate and then you do this canary, it might blow up. That's why we're doing all of this safety stuff around. But anyways, so after we finished with this CD continuous deployment pipeline, it worked quite well, and we started getting feedback from our engineers, right? Because in the end, in this case, they are our customers, right? They are pushing the code, and we have this pipeline that delivers it. Since comparing to the previous version of pipeline, a lot of things changed in the process, right? How things are rolled out, like what is the involvement of engineers. So rightfully so, our teammates had some questions around the processes, right? So they would ask a question, like I merge the code, I know what version of software this code is deployed in, when will this code get into production, right? Or one of the customers, it's not there yet, right? Like why? So these kind of questions. And you know, we would get these questions, we would answer them. And we got to the point where we were getting kind of overwhelmed by the amount of questions and like insights that the team wanted. And we figured out, okay, this is the right time to automate this, right? Like people need this kind of information. How do we deliver it to them? We had already Grafana dashboards, and this information was available, but not readily available, I guess, to the teammates. So we figured out, like, we use Slack a lot. That's where we are naturally at. So we introduced a Slack bot where you can just ping a command and you get all this information right where you're at, right? So we like kind of went where our engineers were and figured out what was the best way to provide this info to them. This worked really well, and we adopted this approach, right? So any other like operation or need that our engineers would have around this process, we would add commands there. So one example was, let's say an engineer proactively detects a regression, right? That happened, like that engineers knew that something was wrong in the code and we needed to halt the rollout process. So instead of them coming to us and asking like how we can do it, we have a simple command: freeze the rollouts, and then the whole release train is frozen. Nothing gets out until someone goes and you know, toggles it on again. So these kind of things we added in the SlackOps kind of style that we are doing today as well, adding more and more of these commands as we realize we need them. Yeah. In terms of takeaways, like thinking back into the whole process, I think we would categorize it into four main things. One is thinking about system constraints, right? The one good thing that came out of it is that we started thinking about what were our constraints from the beginning. And for us, it was velocity, the quality of service, and the scale. Right, that was the main challenges that we had, and having thought about that in the beginning informed a lot of decisions that we made in the architecture of this pipeline. And otherwise, it would be quite hard to kind of navigate and work around them if we didn't think about it in the beginning. So if you have like some big items in your mind about the problem that you're trying to solve, like try to get it in the designing phase in the beginning. At least that worked well for us. Second point was measuring the baseline, so DORA metrics, because we measured it in the beginning and we knew where we were and where we wanted to go. So throughout the whole process, that was kind of navigating us, right? So like if we were making correct choices or if we were optimizing the right thing. So that was really good. And then finally, observability and instrumentation. I think this was the most critical point in the whole design that allowed us to do this automation, because like technically we had all the pieces in place to roll out quickly, but we didn't have like the confidence and necessary feedback loop to do so without breaking things. So really instrumentation was the key, like defining what makes rollout successful for us, what it means to have a healthy environment, define those metrics, these validation metrics, define them on high level specifically for your application, like standardize them, and then instrument it in a way that you can deal with the scale, like with Thanos or any other this type of open source tech. And then finally, identifying and eliminating bottlenecks. So here, our takeaway was that we didn't over-engineer in the beginning, like we didn't start building solutions to anticipate the needs. We didn't build any of the support thing for our engineers in the beginning. Like we just deployed minimum pipeline that we needed, and that's it. And then we started saying like what our engineers needed. And when we figured out that it was overwhelming us in terms of requests and it was becoming a whole separate job, that's when we automated it. So automate when you need to. Basically, don't start with a hypothesis. And that's it. Thank you so much for being here, for staying for this presentation. And yeah, if there's any questions, we'll be happy to answer them.
everyone just wants to, oh, let's go.
Why do you not care about exceptions?
I was waiting. So essentially because there would just be too much noise, and we are in a lucky, okay, it could be lucky or unlucky, but we're just talking about infrastructure code here. We mentioned that we're releasing Elm charts, right? All the code that is the AM product code is decoupled. And we can be very confident that when we are releasing this infrastructure, if you start seeing an issue with the product, most of the time it's decoupled from the infrastructure, and the problem is actually in a different piece of code, right? It's not due to changes we did in the Elm chart. And so it wouldn't make sense to be looking at exceptions in AM itself. But if you start seeing things like, oh, suddenly CPUs are like, we're running out of CPUs to run this system, or things more at the Kubernetes infrastructure level, that's what we care about. Like, we don't care about exceptions in the product itself. Also because there's so much, maybe there would be a way that you could do that if you had a very complex, like, pattern detection thingy that would look at all the millions and millions of lines of logs that we're generating every day. And like when we roll out the infrastructure, if you would detect like a spike in errors, but we don't have that. And to be honest, I don't think we need, because just by looking at these metrics, it has been working quite well. So I think, like, to answer your question, is just there's just too much noise, and they would be irrelevant to us. And by looking at these things, it works already. Yeah, I don't know if you want to.
Yeah, I mean, one thing I would add is, like, in the end, we care about not to break an environment, right? And we have metrics in place, as we said, those validation metrics that tell us whether we are breaking or not. Now, if we figure out that some exception that we didn't care about is suddenly breaking the environment, of course we care, and we will incorporate it in there. But unfortunately, like for as Jose was saying, regarding noise, if there is some exception that does not break the environment, does not degrade the performance to the degree that we say we need to hold, like past our thresholds, then that is something that we can't care about, because otherwise we will never be able to release, or we will need something very complicated, like some system that will be able to deal with that, but we don't have it yet. So,
I think the one learning here is that because the scale is so big, you have to be pragmatic, and you cannot care about every single error that happens in all of these environments, because otherwise you'll not release code, not in 2025, not in 2027.